Hello everyone, welcome back to Data Analytics with me. I am a senior data analyst and this is part 3 of our Power BI series. In this video, you will learn why data modeling is so important and how to build a clean, effective data model in Power BI. If you haven't watched part 1 and part 2, please pause this video and watch them first because data modeling only works when your data is properly prepared. Think of data modeling like organizing a home. Before guests arrive, you can have expensive furniture, good decor, but if everything is randomly placed, people will get confused and uncomfortable. Data modeling works the same way. It's define how your data table are connected so Power BI know where each piece of information belongs and how to use it correctly. Without proper data model, your report may look good, but the number can be wrong. The report can be slow and calculation become complicated. A good data model keeps everything structured, makes reports faster and accurate, and allows you to build professional dashboard with confidence. Do you know what is a data modeling? Data modeling is the process of defining how different tables in your data are connected to each other so that Power BI can understand the data correctly. A good data model usually has fact table that store numbers and dimension table that store descriptive information like product, customer, or region. Why data modeling is important? Because even if your data is clean and your visual looks good, a bad data model will give you wrong result. Now that you understand what data modeling is and why it's important, let's see how to build a proper data model in Power BI. This is a Power Query editor. Here we perform a transformation. I already explained that how to do transformation and data cleaning activity on our dataset. So in this video, we will learn how to do data modeling correctly. I guarantee this will be a useful video. You will rarely find videos that explain data modeling in this way. At the beginning of my career, I learned Power BI mainly from YouTube videos. I never bought any paid course. I learned through YouTube video and real project experience and also guidance from my seniors. In this video, I'll explain why I selected this specific data model. I noticed that very few videos clearly show how to design a data model when you have only one fact table. That gap is exactly this video address. This method was taught to me by my seniors and I still use it in real project today. It works in real industry scenario, not just theory. Many professionals still follow this approach because it genuinely used in real world project. So this is our fact table. Here you can see we have only one table. So we need to create a dimension table. But do you know why I need to create a dimension table? Do you know what is a fact table? What is a dimension table? Do you know the difference and why we use dimension table? So today I will explain all this to you. We mainly work with two type of table, fact table and a dimension table. Fact table store numerical data that we want to analyze, such as sales, amount, profit, and dimension table store descriptive information like date, product, customers, region. So what is the need to create dimension table here? If you don't create a dimension table, all your columns stay inside the fact table. Now, when you try to add category column as a slicer from a fact table, the slicer become heavy. It loads slowly. It may show duplicate value and it it become hard to manage. But when you create dimension table, categorical value exists only once, the slicer becomes clean and fast, filtering works smoothly, and your reports stay easy to maintain. In simple words, I can say that fact table is for a calculation and dimension table is for slicer and filter. That's why even with one fact table with separate dimension because it makes us report usable and scalable. Here we can see that we also have one fact table and we will also separate our descriptive column from our fact table. So here you can see transaction ID is also part of the fact table. Transaction ID, then order date, delivery date, order status. Order status, here we can see it's the descriptive column. Customer ID is also descriptive. Then product category is also descriptive information. Then quantity, unit price, total amount, discount, it stay in fact table. Okay. So we won't separate this column from our fact table. Then region, store, salesperson, payment method, another region. Okay, we have a two region here. Okay, but here you can see this region is different and this region is different. So in that case, we can remove this region from our table. And country. Country column is also the descriptive information. So we will separate our descriptive column from our fact table. So this is our fact table and we are going to create dimension table using this fact table. So first I'll explain this step. Here I replace null value with return. Here you can see in the order status column, I have a null value. So I replace that null value with return. When you are dealing with real data, that time you have to ask this question to your stakeholder that, okay, I have a order status column and in that order status column, I have a null value present. So what should I do? And show them, okay, here you can see the order date and delivery date. So it's here you see the order status is null. Its order date is 1st November 2022 and delivery date is 11 November 2022. That means this item, this laptop, here you can see the product name. This laptop is delivered, but why this is null? So he will explain, okay, you can replace this value or you can ignore this value or don't use this column. We don't need order status for analysis. He will explain. So you can ignore this value or you can replace it. But for every time you should ask to your stakeholder that if any question, any doubt regarding the data, go to your stakeholder and ask them a question. Then I change the column type. Here you can see this is the okay. Here I change the order status column data type. This is the text data type now. We can create dimension table using this fact table. So we can start with region and country column. Just click here, click on your table name, right click, duplicate. Okay, click here, choose column. Now we are creating dimension table for the region. Okay, select region and country column, hit OK. Then you can also remove this step because here we replace a value within a order status column. So you can remove this step because we don't need this step right now. Okay, select this two column, right click, and here you can see remove duplicate option. Here I remove duplicates. Then here you can see column profile based on top 1000 row. Click here and change it into column profile based on entire dataset. Okay, and also change the table name. This is the dim dim region. Okay. So here we created our first dimension table using a fact table, but this is not completed yet. Okay. So go to add column. Here you can see index column. I already explained this to our previous video. If you didn't watch that video, please pause this video and first watch that video, understand that, and then come to this video. So here, so here, click on the drop down from one. Click on from one. Okay. So rename this column name. This is our region ID. Region ID. Okay, so you can also double click here and you can rename column name, but I use this method. Okay, then go here, click on a fact cell data. Okay, in my previous video, I told you that I will use this feature in data modeling video. So just click here, merge query, select dimension table over the dim region, then select region and country, and in the same order here we first selected region, so click on region, then second is country, click on country. So for this, clicking multiple column, you need to use control plus click, and then you can select the multiple column. Now the most important part is here. Every time you merging something, that time you have to see this number here. You can see this selection matches the exact number because here I use fact table to create a dimension table, that's why it's matching properly. So just click on here. Okay, go here, click on this option and select region ID. Okay, in the fact table, now we have region ID. So this is a column that will help to make a relationship between our fact table and dimension table. So next step is go here, choose column and remove the country and region. Okay. Okay. So now you can see still we have order status, product category, and yes, and payment, salesperson name. This is the descript or also the store. This is the descriptive information. So we also need to create a dimension table for that. First dimension table is done. Dimension region. Okay. So now we will create another dim table for our product and its category. So in that table, we will store our product information. For example, product and its category. And the step is same that we applied on dim region. So you can select this table, right click and duplicate. Now here, remove this step, remove this step, click on this icon, retry. Now we will select product and its category. Okay, Here I change the order of columns. So select both the column, right click and remove duplicate. So here we have to change the data type of the column. Select text. This column also text. Change the table name, dim product. So click on add columns, index column, click on drop down from 1. Rename the column name. So I'm using this method. Okay. So why I rename my column using the M query here. Rename my column name using double tap on the header of the column. But if I did this here, another step will be add, that is a rename column name. So I don't want to add unnecessary step on my data. So I change my column name directly here. Same step, go back to our fact table. Okay. So one important note is here. We also have to change the data type of the column for product and category. Change. So this is a text. Okay. This is the text. We will check all the column data types. So this is correct. This is the text data type. When you extract data from a data source, the first step you have to do after extraction is that check all column data type. So here, okay, oh, this is also text. Yes, insert. This is also text. Text. Yes. Then payment method. This is also text data type. Okay. So come here on this step. Expand dim region. Go on the merge query. Select our table name. Okay, dim product. Okay. Um, just a minute. Here we remove duplicate. Come to the fact table and click on this step. Why? Because here I removed region and country column and I don't want to add unnecessary steps. So here what I do, I will do merge query, then I will extract my product ID here and then I will remove product and category column from this table. So click on merge query, insert, select product, then category. Okay. So here you can see I first selected product. So here same step, product, then category. Okay, so here you can see the remove other column. This step you can apply after all the merging and the extraction of the ID column is done. You can apply this step later also. Click here, same steps, click here, click product ID, insert. Now I have a product ID. So come here in this step, click on this icon and remove product and its category column. Click OK. Okay, now we have region ID and product ID, and we remove region, country, category, and product name column from our fact table. And this column, region ID and okay, where is my product ID? Okay, I didn't selected that. Okay, select that. Now the next step is store salesperson payment method, then order status. Okay, so now we will create another dim table to store sales info. So in that table, we can store salesperson name and store's name, like store A, B, C, D. So we can store that information, then payment method and order. Right click on this column, duplicate, remove this step also. Click on this icon. So now I want store and salesperson. Click here, change the data type here. This is the text data type and this is also text data type. Select both columns, right click and remove duplicate. Change the table name. So this is the dim store info. Store info. Click on add columns, index column, start from 1. And then we have to change the column name. That is a store ID. Go back to fact table. Same step. Come here and click on merge query. Insert the step. Select the table dim store info. Okay. Store and salesperson. So store and salesperson. Click OK. Click on this icon, text store ID, insert, click on this icon, and here remove the salesperson and store column. Click OK. Don't forget to like the video, subscribe for more Power BI tips, and share this video with your team or your friends. Now we have a payment method and order status. So now we will create one table to store order status. So we have to create one table to store payment data and one table to store order data. Okay. Here we just have one column. That's why we are doing this. Click here, cli- click on duplicate. Okay, remove this step, all the step. Click on choose column and select order status. Click here, click on a column header, right click, remove duplicate. Now here you can see we have just two values, completed and return. So we can directly map this column with our fact table, but we are following a proper step. So please don't do this. Just click on the add column, index column from 1, order ID. Rename the table name also, dim order. Right click on this column, duplicate, come here, remove other column and select payment method. Click here, then so here we are removing duplicates value from our table. Come here, index. So rename this column name as payment ID. Payment. Come here, merge query, insert, merge with order, order status. Click on OK. Click on this icon and select order ID. Insert. Then again click on merge query And this time we will select payment table. Click on OK. Click on this icon and take payment ID column. So now we have to remove that column. Okay, so remove order status, then payment method. Okay, yeah, I think it's done. Okay, so now we have a transaction ID, order date, delivery date, customer ID, quantity, unit price, total amount, discount, region ID, product ID. Okay, so we didn't select that ID, store ID, order ID, payment ID. Now here we also need to create one dimension table for our calendar, for our date. We create calendar table because Power BI needs a proper calendar to understand time. Think of a calendar hanging on the wall. Even if you don't work on Sunday or there is a no data on a particular day, that day will still exist on the calendar. But in the fact table, Power BI only sees dates where something happened. It completely ignores missing days. Because of this month-wise analysis, year-wise comparison, and calculation like YTD and last year versus this year don't work properly. When we create a calendar table, we give Power BI that full wall calendar. Now it understands all days, all months, and all years. And filtering, slicer, and time calculations start working correctly. That's why we create calendar dimension table in the Power BI. Apply all the changes. You can see Power BI automatically detected the columns. So our data modeling is done. Okay, don't worry, I will tell you. So I already created calendar table, but I will explain you how to create that. And also I have created one video. In that video, I explain this calendar table in detail. So click here, property, and you can see cardinality is many to one. Here we have a four type of cardinality. Many to one, one to many, many to many. So cardinality in Power BI is define the relationship between two tables by describing how many rows in one table are related to row in another table. So we have a different type of cardinality, many to one, one to many, and many to many. So in one to many, one row in one table is related to multiple rows in another table. Many to one is multiple row in one table are related to single row in another table. So here you can see this is our fact table. So it has a multiple record and this is a unique record. This is a unique ID, or we can say this is the primary key. One to one is one row in a table is related to exact one row in another table. Many to many means multiple rows in one table are related to multiple rows in another table. The dimension table is always on one side. So here you can see this is our dimension table and this is our fact table. And fact table is always on many side of the relationship. That's why it's many to one. Now the single and both filtering. So single filtration means here you can see our dim region filtering our fact table and this is the correct way. So in the one-to-one relationship, this filtering is both the side. In your Power BI, if it not automatically detect the relationship, then I will tell you how to do this. Just I'm deleting this relationship right now. Here you can see I have a order ID and in my fact table I have a order ID column. Just drag this column and drop it here. Now you can this order ID. Now this is our dim side. It's mean it's a one. Here you can see one to many. Dimension table is always on one side and fact table is always on many side of the relationship. Click on save. Yeah, that's it. It's done. Now we will learn how to create dimension table in Power BI. So here I already created dimension table. I'm explaining you this code, but if you want a detailed explanation, I already created one video. You can refer that video. So here you can see this is the dim calendar. This is the name of our table. Then I use add column function. Why? Because in the calendar we have a multiple columns. So that's why I use add column. Then I use calendar auto function. Calendar auto function is automatically detect the minimum date and maximum date in our table. For example, in this table we have a two date. Okay. Here you can see we have a order date and we have a delivery date. We have a two dates here, so I use a calendar auto function. I can also use a calendar function and inside the calendar function I can pass mean and max date. For the mean date I will use the order date because we know order date should be always is a mean date and delivery date is always is max. This is a column name. That's why I mention that column name in double quote. Then I use year function for year. Then quarter function. Okay. In Power BI, we have a quarter function, but using that quarter function, we will get the only the number means first quarter, second quarter, third quarter. We will just get the number, but we want Q1, Q2, Q3. For that, I use a concatenate function. Inside the concatenate function, I pass Q and quarter function. Quarter function give the number and I concatenate with Q. Then the month number. So this. Okay, in the Power BI, if we want a month name, that time you need to use format function. Not compulsory to use format function. We can extract month name using the different function. But here I use a format function. Inside the format function, I pass my date column and I gave the format. Here I mentioned 4M means I want proper name means I want full name. That's why I pass 4M. Then here you can see another month because I want just first three character of my month. Here you can see first three character of our month, and this is the full name of our month. So that's it. Then come here data modeling. So where is our calendar? Yeah. Active relationship between calendar and fact table, but the relationship is on order date, but we also have a delivery date. So drag this and drop it here. Okay, so in Power BI we can only make one active relationship between two table. Okay, so this is not active relationship. Click here. So here you can see this is the active relationship and this is the inactive relationship. So this is a star schema. In a star schema, we have one fact table in the center and multiple dimension table connected it directly. So this schema is called star schema because this structure looks like a star. Star schema is the best practice in Power BI because it is easy to understand and gives better performance and make our DAX calculation simpler. Next, we have snowflake schema. In a snowflake schema, the fact table still in the center, but the dimension table are further split into multiple related tables. This structure looks like a snowflake. Although it reduces data redundancy, it increases complexity and can be negative impact performance in Power BI. That's why snowflake schema is generally not recommended unless the data source is already structured that way. Finally, we have the galaxy schema, also we known as the fact constellation schema. In a galaxy schema, we have multiple fact tables sharing common dimension table. This type of schema is used in complex model. For example, when sales, inventory, and budget facts all share the same date, products, or store dimension. This schema is a powerful, but it should be used only when it's required. If this helped you, hit like, subscribe to the channel, and share it with a friend who's learning Power BI. Bye.